An inverse function is a function that undoes the original function. It does the opposite thing. The outputs become the inputs, and the inputs become the outputs. The x becomes the y, and the y becomes the x. So this first function here, f of x, is x over 3. You take an input, you divide it by 3, and that gives you the output. Now the opposite of this function, you would start with the output, you do the opposite of dividing by 3, and it will take you back to the input. So the inverse function, you go backwards, and you do the opposite thing. So the opposite of dividing by 3 is going to be multiplying by 3. So the inverse function, and the notation we use, is f minus 1x. The inverse function is going to be 3x. So this function is the opposite of our original function. So if we put in 30 into our original, 30 divided by 3 is 10. And then we put 10 in to our inverse. 10 times 3 takes us back to 30. It does the opposite thing. It goes from the output back to the input. It's the opposite function. For the second one, g of x is 5x plus 1. Again, we're looking for the opposite function. What is the function that will undo our original function? So with a function diagram again, we put the input in, we multiply it by 5, then plus 1, and then we get our output. So our inverse function, g minus 1 of x, is going to be the thing that does the opposite. So if you start here, you want to take away 1, and then divide by 5 to get you back to where you started. So it's x, take away 1, divided by 5. So this will be the opposite function. It will do the opposite thing. It's the inverse. And then h of x, this last one here, I'm going to actually show you a different way of doing it. So I'm going to write h of x, I'm going to write it as y equals x plus 2 over 5. In an inverse function, the x becomes the y becomes the x, the output becomes the input, and the input becomes the output. So if I switch these x and y's around, I'm going to have x equals y plus 2 equals 5. So I've changed the input and the output around, but now I want it to be y equals again. So I'm going to undo this, so multiply by 5, 5x equals y plus 2, and then take away 2. So y is going to be 5x take away 2. So that is our inverse function, but we don't write it y equals, we write h minus 1x equals 5x minus 2. So that is our opposite function. So if you put something into the original, so if the input was, let's use 8, so h of 8 is 8 plus 2, which is 10, divided by 5. 10 over 5 is 2. So the input was 8, the output was 2. If we put 2 into our inverse, we should get our 8. So 5 times 2 is 10, take away 2 is 8. So the output becomes the input, and the input becomes the output. 3 for you to try, so find the inverse of each of these functions. So the first one is going to be x over 3. So the opposite of timesing by 3 is dividing by 3. The second one, so in this function we're multiplying by -1 and adding 5. Or we could, let's use this method. So I'm going to switch the x and the y around. The y becomes the x and the x becomes the y. Then I'm going to rearrange it to get y by itself again. So plus y and take away x. So we actually find the inverse g minus 1 of x is 5 minus x. And you can say that's self-inverse. So the function and its inverse are actually the same. So if we put 2 into g of x, we get out 5 minus 2, 3. I then put 3 into our inverse. 5 minus 3 takes us back to 2. So it's called a self-inverse. The function itself is the same as the inverse. And then the last one, the opposite of timesing by 2/3 is timesing by 3 over 2. Or with that method again, y equals 2/3 x. X becomes the y becomes the x, and then rearrange to get y by itself again. Y is 3 over 2x. So h minus 1 of x is 3 over 2x. F of x is 2 times x plus 1 divided by 3. State the range of f of x. So what can f of x be? It can be anything. So it's a linear graph, it's a straight line graph. So what can the y's be? So f of x can be anything, a set of real numbers. Determine the equation for f minus 1 of x, the inverse function. I'm going to make it y equals. In the inverse, the y becomes the x and the x becomes the y. And I want to rearrange it so I get my y by itself again. So multiply by 3, take away 1, and divide by 2. So f minus 1 of x, the inverse function, is 3x minus 1 over 2. And sketch y equals f of x and its inverse, f minus 1 of x, on the same axes. So when we have inverse functions, the inverse function is a reflection in the line y equals x, because the x becomes the y and the y becomes the x. So we have y equals x, we have this line here, the line y equals x, and the two lines are reflections over that. So if we write them as linear graphs, y equals mx plus c, we get 2/3 x plus 1/3, and we get 3 over 2x minus a half. So our original 2/3 x plus 1/3, so it crosses at 1/3. It's got a gradient of 2/3, so quite a shallow gradient. Going to have a line like this. So y equals 2/3 x plus 1/3. And then the reflection in the line y equals x is going to look like this. So this one crosses the y-axis at minus a half. And from that, we can figure out that this one should cross the x-axis at minus a half, because it's a reflection. And where we crossed at 1/3 on the y-axis for our original, our inverse should cross the x-axis at a third. The y becomes the x becomes the y. And so they are our graphs. It's a reflection in the line y equals x. The inverse function is always a reflection in the line y equals x. The x becomes the y and the y becomes the x. One for you to try. F of x is 4x minus 1. Pause the video and give it a go. State the range of f of x. Again, it's a linear graph. It can be anything, so the set of real numbers. Determine the equation of the inverse function. So the opposite of multiplying by 4 and then taking away 1 is going to be adding 1 and then dividing by 4. So it's going to be x plus 1 over 4. And sketch them on the same axes. So we're going to have a reflection in the line y equals x. And our original was 4x minus 1. So it's got a y-intercept of -1 and a gradient of 4, so quite a steep one. And then our inverse is going to be a quarter x plus a quarter. So this is -1. So this is going to be -1. So it's going to cross the line y equals x at the same place the other line did, because it's a reflection in the line y equals x. This is a quarter. So this must be a quarter as well, because the y becomes the x and the x becomes the y for the inverse. Another one. So f of x is the square root of x minus 1. So that's not usually a function, but we've got the domain limited. So x is greater than or equal to 1. So that means that makes it a one-to-one function. Only one-to-one functions can have an inverse. Say the range of f of x. So it's going to have to be bigger than 1, which is going to be, well, it can equal 1. So the square root of 0 is 0, and it can be anything bigger. So it's going to be anything bigger than 0. It can be anything greater than or equal to 0. Determine the equation of our inverse function. So let's say y equals square root x minus 1. For the inverse function, the x becomes the y and the y becomes the x. And then rearrange it to get y by itself. So square both sides. And then add 1 to both sides. So the inverse function, f minus 1 of x, is x squared plus 1. So our inverse function is x squared plus 1. Sketch them on the same axes. So again, our inverse function and our function are a reflection in the line y equals x. So there's the line y equals x. We've got x squared plus 1. Now, I should have also said the domain becomes the range and the range becomes the domain. So where the range of f of x was greater than or equal to 0, the domain of our inverse function, x is going to have to be greater than or equal to 0. So we've got a limited domain only when x is greater than or equal to 0. And it's x squared plus 1. That's our x squared graph, moved up 1, but only when x is greater than or equal to 0. So it's going to go through 0, 1. It'll be 1, 2, and then 2, 5, and so on. So it's this graph. It's half of the x squared graph. So only for the positive side. And then the inverse, or the original, is going to also cross at 1. And it will be a reflection. And one for you to try. So pause the video and give it a go. So f of x is x squared minus 1, where x is greater than or equal to 0. State the range of f of x. So we can put in anything greater than or equal to 0. So that's going to be its minimum point at 0. So it's at -1 is the minimum point. So it can be anything bigger than or equal to -1. Determine the inverse equation. So if y equals x squared minus 1, in the inverse, the y becomes the x and the x becomes the y. And let's rearrange it to get y by itself. So y is going to be the square root of x plus 1. Y is going to be the square root of x plus 1. And the domain becomes the range, and the range becomes the domain. So the domain of this is going to be x is going to have to be bigger or equal to -1. So we can only have values of x bigger than or equal to -1 because the range becomes the domain and the domain becomes the range. They switch over for the inverse function. So it's square root x minus 1 for when x is greater than or equal to -1. And then we're just going to sketch again, because it's an inverse function, they're going to be a reflection in the line y equals x, because the x becomes the y and the y becomes the x. So our original was x squared minus 1. So the x squared graph down 1. So it's going to look like this. So it crosses here at -1, and it crosses the x-axis at 1. The inverse, square root x minus 1. So the x becomes the y becomes the x. So we're crossing at -1 and 1. It's going to cross the line y equals x at the same point. So we have this. One more. So f of x is ex plus 2. State the range of f of x. So our e graph is this one. So it's usually anything bigger than 0, but it's moved up 2 spaces. So it's f of x is greater than 2. It's usually bigger than 0, but moved up 2 spaces. It's the same as f of x plus 2. The whole graph moved up 2 spaces, so f of x is greater than 2. What's the equation of the inverse function? So if the original is y equals e to the power of x plus 2, in the inverse, the y becomes the x and the x becomes the y. Rearrange it to get y by itself. If we log both sides, so log x minus 2 equals y. So the inverse is log x minus 2. So it's log x minus 2. And again, the domain of this is limited to x is greater than 2. So let's sketch our two functions. So we've got a reflection in the line y equals x. Again, that's always the case for inverse functions. And let's sketch our original. That's going to be easiest. So we've got an asymptote at x equals 2. No, y equals 2. At y equals 2. And it usually crosses at 1, but it's moved up 2 spaces, so it's going to be at 3. So something like that. So that's our original. The inverse, the asymptote's moving to x equals 2. It's crossing the x at 3. And it's a reflection. So it looks like this. One for you to try. Pause the video and give it a go. Part A, state the range of f of x. So in our log graph, we have this shape. There's no limit on the range. There's no limit on what y can be. So x has got to be greater than 1. So there's no limit. F of x is a set of real numbers. Determine the equation of the inverse function. So if y equals log x minus 1, for the inverse, the x becomes the y becomes the x. Take it out of log form. So have x equals y minus 1. Add 1 to both sides. So y equals e of x plus 1. E of x, e to the power of x plus 1. And we're going to sketch the graphs. So again, a reflection in the line y equals x. I prefer drawing my e graph, so I'm going to do that first. So e to the power of x plus 1. So the asymptote is moved up to y equals 1. It's going to cross at 2. So it's this graph and the inverse. So the asymptote moves to x equals 1. It crosses the x-axis at 2. And it is the reflection. So it's shaped like this.